This is the pre-lab for the reaction order and rate law lab. When you make your solutions, I want to take a picture of your solutions with the 24 whatever well, or is it 12? No, we'll take a picture of your well plate. I guess it's 12. Uh, so and if you want, put something in the picture. You don't have to. You just I think it makes it fun. Or even you can be something boring like a coin. It doesn't have to be something fun. This one's getting a little more dangerous. So be sure to wear your gloves and goggles with glasses, I should say, with this one. It's mostly for the hydrochloric acid, and I mean you don't want to touch the sodium thiosulfate either. But let's talk about. Well, let's go to the lab here. So let's explore. Hopefully, you've already done chemical kinetics, and I mean we have it in the first part of the quarter for here, and so. But let's just move on and get to how you break down this lab. So explore reaction rates, and hopefully this is a bit of a review. The reaction rate is independent of concentration. This is also known as zero order, and this can be other orders. So the concentration and just with time, it doesn't matter what concentration you have of that reactant. The reaction rate just kind of goes, and and we're having two things. We're having hydrochloric acid and sodium thiosulfate. And so the rate for this is going to be, the rate is equal to some rate constant times the concentration of A raised to some power of N, concentration of reactant B raised to some power of N. So with this experiment, we're going to figure out what these exponents are, M and N. And then after that, we can figure out what the rate constant is. So I know submit. So zero order are independent. So just because you have reactants does not necessarily mean they're going to participate in the rate law. So for this equation here, carbon monoxide, for instance, does not participate in the rate. First order basically, and most things are first order. So if you double the concentration, you double the rate. That's first order. Second order and high order, it's 2 to whatever the power is. So for second order, if you double the rate, you quadruple it, or 2 squared. If it's third order and you double it, it brings it by 8 times. So 2 cubed for 8 for that. So I know, and you should be doing the questions. I'm just blowing through this. So but you're going to make this chart here. Well, you're not going to make the chart, but you're going to be looking at this. And the way you look at these data, because they're not going to be as nice and even as for you, you're going to look at the rate of experiment 1 or the rate of experiment 2, and you're going to have the rates there. Well, I guess I should go in the formula. So it's just the rate constant times the reaction species first, raised to some power, second one raised to some power. And if you have them even, you can cancel these out. So these concentrations, so we're gonna keep some of the concentrations the same. So you can see here the rate constants and then the concentration of the other things cancel out, and you're left with a number raised to the power. And then from this, you can, showing here with using natural logs, using logs, you can figure out what the value of that is. And this is 2.07, but in this case, you're going to call it 2. So you're going to bring it to the closest integer. I know you can have fractional ones, but for this lab, that they're integers. So hint, hint. And same idea with the other one. You can look at if you have one species, and you can look at the other, and then you get the values of M and N. So now you know the rate is equal to some rate constant, nitrogen monoxide squared, oxygen to first order. And then now the way you figure out the rate constant is you pick any value of the rate, you put in the rate, and then you put in the concentrations. Now you solve for the rate constant. And also with the rate constant, make sure you get the units done properly. And usually when we have the units, we put it up like this. And I think the reason why we do this is because of old school typewriters, to be honest with you. So, but this is the way we typically write it in chemistry. So hopefully you can come back to this page if you're having a hard time trying to figure out how to calculate out the different parts, because this is going to be a part with the experiment. But I think this goes through and it shows you pretty well how to break down the data. Okay, so and you go to experimentation, and well, let's talk about the materials. So, but I also want to emphasize safety. So this stuff is more dangerous. I mean, we're just using books and Boyle's law, and we're using red dye and the Beer's law. Now you're working with some stuff that can hurt you. So make sure that you're away. Keep it away from children to from your children or little siblings if you have them. Also from pets, right? So you don't want your dog or cat to get injured from this as well. Oh, it's a 24 well plate. I thought it was 12, but okay, so 24 well plate. So okay, and one thing with this, if you are make sure your well plate is clean. So make sure you have a clean well plate when you're doing this. And this is what's included in your bag. So let's talk about then the rate law experiment. So we're going to look between hydrochloric acid and sodium thiosulfate, and this is a reaction. Specifically, what you're looking for is a sulfur. You're going to put an X. I guess that comes down later. Yeah, you're going to put an X in the bottom of your well plate. Well, you put it on a piece of paper and you move the well plate. But when this X disappears from the deposition of sulfur, that's when you say it's over. When you say this reaction is over. So I know it's not the best, because I mean it's a little subjective. Like when am I not seeing the X? So, but I mean, do as best you can. And obviously, so this is a rate. We're going to have rate is some rate constant, concentration of HCl reactant raised to some power, thiosulfate raised to some other power, and we're going to figure out what the M and N are. And so first thing I'm going to do, I'm going to vary the concentration of the hydrochloric acid. And you can see, so you go through this, and you add so distilled water to these various places, and then from the hydrochloric acid, HCl, add the drops here as such. And then and you're not going to vary the concentration of sodium thiosulfate. So in the equations that we showed before, these are all going to cancel. So you can see that you have these here, and you're varying the concentration then of hydrochloric acid, and then you're going to you already mentioned that. So use the permanent marker, get one of the short stem pipettes, and label the bulb of empty short stem pipette Na2S2O3 sodium thiosulfate. So and put it so that the plate C1, so this is C, and you can see the little things on the side, and then 1 is over the X. And then, of course, tip it forward, but try not to spill any of the other solutions. So, but then you suck up all the sodium thiosulfate, and then you put the well plate back down, and then you get your timer. Oh, and so you use a watch. I just use my cell phone. I think everyone probably has access to a timer on the cell phones, on the smartphones. So that's what I've been using for this. But you can anything that will record time, and you need it in seconds. So by the way, so then put the stuff from the sodium thiosulfate from the pipette you've labeled, and then put in well C1, and then start timing. And then when you can no longer see the X, then stop. And then record this in the data table, and then keep on doing this for the other ones. So, and then you determine the reaction concentrations of hydrochloric acid and thiosulfate by this way. So, if you have the stock solution, so like so yeah, I can see here goes through, and this is a way you can calculate out the concentration. So, and that's important, of course, when you're doing the calculations. So, and yeah, this point here, it's doing the two, averaging the two rates makes the data a little better. So, and then go through and put in the data table, and then calculate the rate for each. So once you do that for hydrochloric acid, you're going to look at the sodium thiosulfate, and this time you're going to hold the hydrochloric acid constant, and then you're going to vary the sodium thiosulfate. And so same idea, add the different concentrations, 6 drops and 8 drops to C5 and C6, and then add these to the various ones. And you can see, so you have here hydrochloric acid and then the thiosulfate. And then take a pipette labeled HCl, and then put an X, so in this case C4, so this one's C4. Then same idea, suck up the hydrochloric acid and stick it in the C4, and then take the time. And then gather those data, and then do that for the rest. And so we'll also get all the concentrations for hydrochloric acid and thiosulfate, and then get the average time. So cleanup is there, and the questions, I got to be very careful because I unfortunately have the answers in front. Isn't that the student view? Let me see the student view, so you don't have to see the answers. Yeah, okay, good. So here are the questions, and these are also the questions in this reaction order here. So, and figure out the order for hydrochloric acid and sodium thiosulfate. And then from that, you can write the rate law. And then, and using this rate law, calculate K from this. So you also need to calculate the rate constant for this one. And this just shows you, it's how you do it. And hopefully, like I said, we've done this before in the chapters, so hopefully this is a bit of a review. And then describe the sources of error. I've kind of hinted to some of that in this talk. But again, I think this one's relatively straightforward while I'm saying that. And of course, I have a PhD in chemistry. But please do be careful with this one because of the hydrochloric acid, and make sure that you're properly covered, especially with your eyes. Hydrochloric acid, this can hurt your skin, and like I said, watch out for other people. Don't do this where you eat food as well. So pick a different area of your domicile to work for this one. So. Okay, but please let me know if there's any issues. And then when you go through, don't forget to submit the report. So you get the evaluation, you get the final report. So go through everything and include then your final report with the course, or with the course, with the lab report when you upload it to Canvas. So, all right, well, happy exploration. And again, let me know if there's any issues. Aloha for now.